This is a Code Ninja Security Advisory. We're tracking a critical vulnerability designation CVE-2026-33626. The perimeter is active, so I need you to listen closely.
12 hours and 31 minutes. Let that sink in for a second. That's how long it took from the moment this was publicly disclosed on GitHub to the first time we saw it being actively exploited in the wild. The weaponization window, it hasn't just shrunk, it's completely collapsed.
All right, let's get right into it. We're going to start with the initial threat disclosure. Think of this as ground zero. This is where we need to start to fully understand the threat vector. So, what are we looking at here? The vulnerability is a high-severity server-side request forgery. That's SSRF for short, and it's rated as 7.5 on the CVSS scale. So yeah, it's serious. It's in the vision language module of the LMDeploy toolkit, which, as you know, is a really popular framework for serving large language models. And look, as AI becomes more and more central to our infrastructure, its supply chain is becoming a prime target. Make no mistake, this isn't some minor bug. It is a direct gateway into your network.
The scope of this problem? It's crystal clear. If you are running any version of LMDeploy before version 0.123, your systems are exposed. End of story. You have to assume you are vulnerable until you get patched. Now look at this timeline. It tells the whole story. At 15:04 UTC, the advisory goes public on GitHub. By 03:35, the very next morning, we're talking just 12 and a half hours later, our honeypots detect the first attack, coming from a Hong Kong-based IP. The key takeaway here, the thing you absolutely have to understand, is the speed. These attackers aren't waiting around for some fancy, polished proof of concept to drop. The advisory itself, that is their playbook.
So why are we putting this out? Our objective is simple. We're here to arm you, the defenders, with immediate, actionable intelligence so you can mitigate this threat. And yeah, we're also here to apply pressure to get a comprehensive vendor patch out there. We operate on the front lines, and this is our report back to you.
Okay, before we get into the nitty-gritty, the deep dive, we need to do a quick comms check. Let's establish a secure link. This is just standard operating procedure for us, and it's how we make sure you get future threat intel in real time when it actually matters.
So, follow this simple protocol. First, subscribe and make sure you enable notifications. This is your direct line to real-time intel from us. Second, hit the like button. Think of it as your formal acknowledgement, your ACK, that you've received this transmission. And third, and this is important, comment with your status. Just type patched or vulnerable. This gives us and the whole community a much better idea of the potential blast radius of this thing. Comms link established. Good. Let's move on to the deep dive. Now we're going to dissect this attack vector and walk through the exact defensive protocol you need to follow to secure your assets.
First things first, you have to understand the blast radius. We're not talking about popping one server here. A successful exploit gives an attacker a wide open door, a significant foothold inside your trusted network. So let's take a look at exactly what they can get their hands on.
The crucial thing to grasp is what this access actually gives them. First up, they can snatch IAM credentials straight from cloud metadata services. I mean, these are basically the master keys to your entire cloud kingdom. Second, they get access to your internal data stores. We're talking Redis, MySQL, where all your critical data lives. Third, they can turn your own server into a beachhead to start scanning your private network, looking for other juicy targets. And finally, they can hit you with a denial of service, shutting down your AI model and use that foothold to pivot to other critical internal systems. The potential for damage here is, well, it's massive.
So what's the root cause of all this? It's ridiculously simple, and that's what makes it so dangerous. There's a function called load image that was built to, well, load images from URLs. The fatal flaw? A complete lack of validation. It just blindly fetches any URL you give it. So in the hands of an attacker, what happens? Your shiny AI inference engine instantly becomes their own personal, unauthenticated HTTP client running deep inside your private network. When we reviewed the attack telemetry from our honeypot, what we saw was a brutally efficient operation. We captured the threat actor's entire session. And you know how long it lasted? Just 8 minutes. This wasn't some kid messing around. This was a fully scripted, automated attack. The attack was absolutely methodical. Phase 1, they go straight for the jugular, probing the AWS metadata services for credentials, then immediately pivot to scan for a local Redis instance. Phase 2, and this was fast, just 51 seconds. They confirm they have a way out to the internet using a callback, and then they start scraping the API for hidden endpoints. And finally, phase 3. They try to disrupt the model by hitting a kill switch endpoint, and then they run a rapid-fire port scan on the local machine for other services. Believe me, none of this was random. It was a scripted surgical strike. Okay, this brings us to the most critical part of this entire advisory, your defensive protocol. These are the immediate actions you absolutely must take to shut this threat down.
Execute these steps right now. Number 1. Upgrade to LMDeploy version 0.123 or later. This is non-negotiable. Get it done. Number 2. Enforce IMDS version 2. This is your single highest return control. It basically neutralizes this entire SSRF technique. Number 3. Lock down your network. Restrict all non-essential outbound traffic from your inference nodes at the VPC level. And finally, number 4. Assume you've been breached. If you are running a vulnerable version, you must rotate any attached IAM credentials immediately. Don't wait. All right, let's wrap this up. I want to take a moment to talk about the why, the ethics and the strategy behind a public disclosure like this. You might be wondering, and it's a fair question, why disclose this publicly? Aren't you just telling more attackers how to do it? And the answer is, the operational reality of our field has fundamentally changed. It's because the advisory is the exploit now. The second these details go public, any motivated attacker can reverse engineer a weapon from it. They are not waiting for some prepackaged tool to drop on GitHub. Our responsibility, our only responsibility in this situation, is to you, the defender. You need to know about this now so you can patch now. The race has already started and you were in it whether you knew it or not. All right, that concludes this advisory. Implement the protocol, verify your assets, and stay secure.